Welcome to my YouTube channel. You're most welcome. Today we are going to discuss about normed spaces. Normed spaces. I'm going to look at normed spaces in today's session. So, a normed vector space is a vector space over a field. A normed vector space. A normed vector space is a vector space. I can call it V, vector space V. I'm calling it V, vector space V over a field, vector space over a field. That one, vector space over a field. That one over a field. That one together. Vector space together with a real valued function, together with a real valued function, together with a real valued function called the norm, satisfying the following properties. So it's a vector space over a field F together with a real valued function which we are calling a norm, satisfying the condition. Sorry. This is supposed to be real valued function, satisfying the following property. Now we have the first property, which is a property of definiteness. Property 1, which I'm calling N1. Norm with respect to x should be non-negative for all x in V. That is the first property. Now the second property, which I'm calling capital N2. Property number 2. Norm should be 0 if and only if x is 0. Number 3. Property number 3. Alpha x, this should be the same as alpha x for alpha being a scalar, where alpha is a scalar, and for all x in our vector space. For the triangular inequality, x plus y, this should be less or equal to x plus y for all xy, for all xy in V. So we have those important definitions. So a norm is a vector space. Whenever we are having a space, that means metric space, normed space, we are supposed to be having that space together with should I call it a set, together with another function. We are having a vector space we're having a set together with a certain function. If it's a metric space, we are having a set X together with a function which we call the metric. So here we are having vector space V together with a function which we are calling a norm. So a normed vector space should satisfy these four important properties. Now, before I end this session, there is something which I want to prove. Let me call it proposition. It's something which I want to propose. Absolute difference. Let X be a normed space. Let X be a normed space. Then for all X, Y in X, comma, this difference here is strictly less or equal to that. We have that important property. Let X be a normed space, then this absolute difference here is strictly less or equal to that. So proof. So here it suffices to show that we show that first of all, we have to first think about what this means. If I'm having absolute A less than 5, this implies that negative 5 is less than A is less than 5. The implication of this is this. Now this should imply that what I want to prove is this is what I want to prove. So it suffices to show that negative X minus Y is less or equal to this, and this is less or equal to X minus Y. So this is what I want to show. I can prove this, then I also prove this. Combine the two results, and you have that. Let us see how to deal with that important notion. That important notion. Now, I'm going to let, should I say letting? We know that this X can be written as X minus Y plus Y. Let me evaluate the norm of this. If I evaluate norm of X, so this is equal to norm of X minus Y plus Y. X minus Y plus Y, and this is the same as X minus Y plus Y. Applying the triangular inequality, this is strictly less or equal to X minus Y plus Y. This side I'm having X. Now I can take this side, so I will have this minus that star. So here I've used x. I'm also going to let y to be x, to be y minus x plus x. Get the norm of y. This is equal to y minus x plus x, and this is the same as y minus x plus x. Applying the triangular inequality, this is less or equal to y minus x plus that. And we know that this is the same as having x minus, the same as having -1 x minus y plus x. So this is equal to -1. We are applying the third property, number 3, yes, to factor out that negative. So this is the same as x minus y, then plus x plus x. So we shall have this being equal to x minus y plus this. I can take x the other side. So taking x on the left hand side, I'll have this minus this. This is equal to x minus y. We can factorize out the negative. Is it? Okay, this is sorry. This is less or equal to. This is equal to this, yes. So here I'm not having less. This is the same as this. So here I'm having less or equal to. I can do what? Now I can combine the results. I have this. I also have that. But I'm missing something. Is it? Yes. Let me pull out the negative here. Let me pull out the negative. This is the same as x no minus y no greater or equal to negative x minus y. I can call this star 2. If you pull out the negative and you divide, you multiply by that negative on both sides, this inequality will change. Now combining star 1 and star 2, combining this and this, we have, if I combine both of them, what do I have? I have, let me start with this. I have negative x minus y. This is less or equal to x minus y. And this from this is this here, this thing here is less or equal to x minus y, sorry. So this implies that absolute difference of norm of x and norm of y is less or equal to x minus y norm. So that's what I'm having. Thank you for listening. Kindly subscribe to the YouTube channel.